Hey guys, I'm back with a new video. In this video, we will be covering about the Ruby programming language. So I'm on the official docs of the Ruby language. So here you can see it says Ruby is a dynamic open source programming language with a focus on simplicity and productivity. Now it has an elegant syntax that we will be seeing in this video. Now Ruby has one of the most elegant syntax. Now it is an interpreted high-level general purpose programming language. Now when you will look at some Ruby code, it will likely remind you of some other language as you have used, and this is on purpose because much of the syntax is familiar to languages like Python and Java. So if you have used those languages, then learning Ruby will be extremely easy, right? So without further ado, let us start with a basic introduction to Ruby, and then we will dive much deeper into the constructs of the language. Now if you want to follow along with me, you can install Ruby onto your system, or you can create a new account on replit.com, and here you can click on plus and create a new REPL. So here you can search for Ruby and then click on this, right? So I have already created one here. Now let us get familiar with the basic syntax of the Ruby language first before we proceed to the basic constructs. Now here let us write a very simple program in Ruby. All the Ruby files will have an extension of .rb. So let us add some code here. Now here if we want to log something to our console, we can use the puts statement. And here we can say double quotes. And here let us say hello to Ruby programming language. Let me zoom this up a bit. And here click on run. So our console says hello to Ruby programming language. And now let us straight move to the concept of variables, constants and literals. Now variables, as we know, are containers or the memory locations which hold any type of data that we want to use in our program. And there are a couple of types of variables that we will see later. So to define a variable, we can use a name first. So let us say first name and set this to Alex. And then let us define another variable, last name, set this to James. And let us print this out to the console, puts first name and puts last name, like this. So let us run our file. And you can see this gives us Alex and then James. Now let us talk about constants in Ruby. Now to define a constant, we make use of an uppercase letter. So here let us define a constant, pi, and set this to a value 3.14. Now here let us take another variable radius and set this to a value 5. So let us print the area of the circle that has the radius of 5. So area, and set this to pi into radius into radius. So we are multiplying pi with the radius, and then whatever we get, we again multiply it with the radius. So this gives us the area. So let us print it to the console, area. Let me remove this quotes from here and from here as well. We don't need them. So let us run our file. Okay, so we get 78.5. So now we are done with constants. Let us cover about the basic literals that we have in the Ruby language. So the first one that I would like to cover is the integer numbers. Now Ruby supports integer numbers. So any integer number can range from -2 raised to the power 30 to 2 raised to the power 30 minus 1. So let us dive into the docs, and here click on documentation. So here you can see numbers in Ruby. So the Ruby language supports integer numbers. Any integer number can range from -2 to the power 30 to 2 to the power 30 minus 1, or 2 to the power minus 62 to 2 to the power 62 minus 1. Now the integers that come within the range that I just mentioned are objects of the class fixNum, and the integers that lie outside this range are stored in objects of class BigNum. So let us see a couple of examples. So back to my IDE, if I here say puts 1, 2, 3, this is an integer. Then if we want a fixNum decimal with underline, so we can say 1 underscore 2, 3, 4. Then we can have a negative fixed num. So puts minus 500. Then we can also have an octal. So puts 0366. Now if we write integers using a leading sign, so an optional base indicator, so here 0 stands for an octal character. Now if we say 0x and then say ff, this is for hexadecimal. And if we want a binary, we can say 0b1211. So a leading optional base indicator followed by a string of digits. So here we have 1211 after 0b, and here after 0x we have f, right? Now let us move forward to floating point numbers. So Ruby also supports floating point numbers, and they are also numbers but with decimals. So the floating point numbers, they are objects of class float. So objects is something we will discuss a bit later in the video. So let's log a floating point number. So 123.445. Let us run the file. Okay. Yeah, this should be 1011. So for binary of 1011 we get 11 because this is the binary representation of the integer 11. And for ff we are getting 255. Now 366 in octal is 246, and for 1_234 we get 1234, right? Now let us move forward to a very important literal, which is strings. Now Ruby strings are simply sequences of the 8-bit bytes, and they are also objects of class string. So we have double quote strings or we have single quote strings that we can use. So if you see these two variables, these are strings. So let us work with them. Now it is pretty common to want to combine multiple strings into a larger one, and we can do this in a couple of different ways, like adding them together using the plus operator. So let me show you this. So let's say if we want to print the full name of the person, the full name, let's refer to the first name plus let's give some space and last name, and then we can say puts full underscore name. So let us run the file, and here you can see we are getting Alex James. Now we can also embed values inside another string. So to embed a value, we need to interpolate that value inside some string, and this concept is known as string interpolation. Now this results in cleaner code since you don't need all those plus symbols like we are doing here for concatenation. So here let me print something here using the puts statement. The full name is, and now to interpolate we need to use a special syntax. So we need to use hash and then double curly braces. Now within this opening and closing curly brace, we need to specify the variable that we want to interpolate right inside this string. So let me put the full name right here. And now let us run our file. So this gives us the full name is Alex James. So using the string interpolation syntax has an additional benefit that it will automatically call the to_s method on this variable, right? So to_s, this one, right? It automatically calls it for us. So if I declare a variable age and set this to 12, so here if I say the age of the person is, and again use this special syntax and add the variable age like this, this age variable will automatically get converted to its string representation. So this means you can use any objects without running into some exception, right? Now a key note to take away from this is that you need to use string interpolation. To use string interpolation, you need to use double quotes. A string in single quotes ignores all these special characters, right? Now we just learned how to add together two or more strings using the plus operator, but then there is another way to do this as well, and we can use this less than symbol for concatenation. Now the difference is that the plus operator gives us a new string, right? A brand new string, while this symbol does not. So here let us add a variable, and let's name it as sentence. And here I will say a quick brown fox. Now to concat, we can say sentence less than, and here I will say jumps over the, then go to the next line and say sentence less than, lazy dog. Let me give some space, and now let us print the sentence to the console. So puts sentence, and now let us run our file. So this gives us a quick brown fox jumps over the lazy dog. So in essence, using this is always going to be faster than the plus operator. Now let us see about how we can manipulate strings. So manipulation. Now there are a couple of ways that we can use to manipulate a string. For example, we may want to split the string into different parts, or we may want to replace them all together. So we may want to replace certain words in a particular string. So for this we have a gsub method, which stands for global substitution. Now this is very useful if we want to replace parts of the string, or we may also want to remove them. Now here let us say we want to replace this dog with a cat. So we can make use of this very powerful method to achieve this. So here let us say puts sentence, and then I can say global substitution, which is gsub, and here we can say replace the dog word with the cat. And now let us run our file. So this gives us a quick brown fox jumps over the lazy cat, right? But one interesting thing to observe here is that if I log the sentence to the console and run the file, you can see that the global substitution does not modify or mutate our original string, which is sentence, right? It only substitutes the word dog with cat on this line, right? It doesn't modify our original string, which is sentence. Now let us proceed further and see how we can split strings. So we can also break a string into pieces using the split method. Now this method looks for a separator character, so we need to specify. So let us make use of this split method to split our string at a specific character. So let us say sentence, and here I can apply the split method. I want to split at a single space, and whatever this method returns us, let us store this in a variable, say words, and let us print the words to the console and run our file. So you can see this splits the entire string at single space, so it gives us a quick brown fox jumps over the lazy dog separately, right? So it splits at this space character. As another example, let us say we have some code abc_123, and let us split the code at underscore, and now let us run the file. So you can see this gives us abc first, so it splits the string at the underline character. So it first gives us abc and then 123, right? So by default, if the split will use a white space as separator, but you can use anything you want, right? So essentially this gives us an array which you can put together again by using the join method, and we'll learn about arrays a bit later. Now let us proceed further and see how we can work with substrings in strings. Now another thing we can do with strings is to use array-like indexing, just like we have in other programming languages. So if you are familiar with JavaScript or any other language, we have the concept of arrays in which we can use indexing to access a particular element that is sitting in the array. So we can get one character or some of them using this substrings. So let us see an example. Let us create a variable greet and set this to hello world. Now let's say we want to extract a certain portion of this string. So starting from index 0 and go until index 3, which is this small l. So puts greet, and then we can use array like indexing. So 0 dot dot, and to which index we want to use as our end index. So it is 3, and this should give us HELL. So let us run our file. Okay, so we get hell. Now if we want to refer to the last character of this string, we have a couple of ways to do this, but the easiest way is to say puts greet and use the index of -1. So this means start from the right end of the string and pick the last character, which is referred by this index of -1. So let us run the file. Okay, so this gives us D. Now this string class has many other useful methods that we will see a bit later. Now the string class also has a couple of other useful methods. To convert a string into uppercase, we can say greet dot upcase. Then to convert to a lowercase, we can use the downcase method. Let us run the file. Okay, so this gives us hello world in uppercase, hello world in lowercase. Then say if we want to capitalize the first character, we can say greet dot capitalize. And then let us say we want to reverse our string. So we can use the reverse method for this. If we want to check whether a particular character is a part of the string or not, we can use the include method. So greet dot include, and here let us say small w, then puts, and here let us say if we want to see whether the string starts with h or not, so greet dot start with small h, and greet dot, let us say if we want to see whether the string ends with a particular character, which is say small l. So let us run our file. So we are using it incorrectly. If you refer this article, you can see. So to use it correctly, we need to use the include keyword, then the question mark, and then the element that we are looking for. Okay, so this should be include question mark w, like this. And now let us run our file. Okay, for this also start with question mark and then h. And now next we need to check whether our greet string ends with L. So let us run our file. Okay, so now it's working. So the string hello world does includes W. It does start with small h and it does not end with small l. So if I put small d here and now run the file, we get true for all the three, right? Now let us proceed to the next concept in which I would like to discuss about immutability and frozen strings. Now strings in Ruby are mutable, which means that you can manipulate or mutate them. Now this has some implications over the performance and memory usage of our Ruby programs. So mutable strings are one of the reasons that we have symbols in this language. So let's take an example for this. So for the same string hello world, let us try to mutate or change this first character that we have in this string. So for this we can say greet and use the indexing 0 to refer the first character, which is small h, and change this to say empty quotes. And now let us print greet to the console, run the file. So you can see this gives us ELLO and then world, right? So h is gone. Now what if I make this string which is the greet string, an immutable one. So let us try making this string an immutable one by using the freeze method. So here I can use the dot notation and say freeze. And then if we try this operation and run our file, you can see it gives us an error, cannot modify frozen string, right? So trying to modify a frozen string will give us an exception. So it raises an exception, which is the frozen error. So if you want to learn more on mutable and immutable objects, you can refer this link. The link for the same can also be found down below in the description section of this video. Now if you see this page, it says that immutable objects have many desirable properties. They are thread safe, that the threads cannot corrupt what they cannot change, right? It also makes it easier to implement encapsulation, and they also make good hash keys, something that we will see later. Now regarding the freeze method that we just saw, so in the class object, it prevents you from changing an object. So it effectively turns an object into a constant, right? Now after we freeze an object, any attempt to modify its results gives us a type error. Now if we want to check whether a particular object, or say a string in our case, is frozen or not, we can use this frozen question mark method, right? So let me copy this. So down here if I say greet dot frozen, and if I run the file, let me comment this. So you can see it gives us true, which means that the string hello world is currently in the frozen state, right? So this frozen string can in turn be used as a symbol in Ruby language. Next, let us talk about the object ID method. So using the object ID method, you can get the internal ID of any object. So with this ID, you can verify whether the two objects are the same, that is whether the two objects are sitting at the exact same memory location or not. So let us define a string. So string underscore 1 Tommy, and here let us apply the freeze method, and then on string 2, here I will again say Tommy dot freeze. And now if we try to compare the string 1 object ID with string 2 object ID, this should give us true. So let us run the file. Okay, so we get true. Now contrary to this, if we have two non-frozen strings, we will get different object IDs, even if they have the same content. So if I remove this and then run the file, you can see now we are getting false. So we just saw that we can use this frozen method to check if a string is frozen or not. Now freezing, as we just saw, is not limited to strings. Any object can be frozen. Now once an object has been frozen, it cannot be unfrozen. So we need to be careful when freezing the objects that contain other objects. Like an array, the contained objects won't be frozen. Make sense? So freezing is only a single level deep. So now let us proceed forward to arrays in Ruby. Now if you are already familiar with arrays, then it's okay, but if you are not, then let us do a quick refresher about arrays. Now arrays, as we know, is a collection of elements that are stored at contiguous memory locations, and the idea of arrays is to store multiple elements of the same type together. So this means, so they are indexable, meaning that we can refer to each element using a special syntax. So we can use the square brace notation with the index, and the first element is referred by an index of 0, and indexing, as we know in programming languages, start with an index of 0. So arrays are a very fundamental part that you most likely use. Now in Ruby, you can store anything in an array, from strings to integers and even other arrays or objects. So the elements in an array are accessed using their index, and that starts from 0, right? Just like we have in other languages. So let us create a new array right here. So superheroes, and here let me say Spider-Man, Superman, and then Goku. Now to work with an array, we need to create it first. So we can create an array like this. Now let us see a few different ways that we can use to read, add, and delete heroes from this superheroes array. So let us access first each element by the index. So puts superheroes, and to refer the first element we can use the index of 0. Then let us refer the second element, use the index 1, and for the third element use the index 2. So let us run our file. Okay, so we get Spider-Man, Superman, and Goku. Now we can also print the first element of the array directly and also the last element of the array by using the first and last methods respectively. So we can say printing first element of the array. So puts superheroes and dot first, and puts superheroes dot last. So let us run our file. So this gives us the first element of the array is Spider-Man and the last element of the array is Goku. Now what if we want to print just the first two elements of the array? We can also make use of an optional argument that the first method takes, which allows us to get more than one element from our superheroes array. So we can say puts superheroes dot first, and here pass the optional argument which is of integer type, as you can see. So we can say 2, and this should give us Spider-Man and Superman. So let us run the file. Okay, so we get Spider-Man and Superman. And if we want to get the last two elements of the array, we can say put superheroes dot last and use 2 as the argument. So run the file, and this gives us Superman and Goku, right? So here let me add a comment, printing first two elements of the array, printing last two elements of the array. Now what if I want to add a new item to the array? So for this we can use the push method. So let us say superheroes dot push, and then use a space and specify the superhero that we want to add. So here let us say Batman, and then let us print the superheroes array to the console. So let us run our file. So this gives us Batman. Now as an alternative, we can also use this syntax for adding a new item at the end of our array. So let me give you an example. So superheroes, and use this less than symbol. Let us say Hulk, and let's put the superheroes to the console. Run the file. So this gives us Spider-Man, Superman, Goku, Batman, and Hulk. Now what if I want to delete the last item? So we can say last hero and say superheroes dot pop, and now let us print our last hero to the console and our superheroes to the console as well. So run the file. So this gives us Hulk first, which is the element that got popped from our superheroes array, and then for superheroes array we are now left with 4 elements. So Spider-Man, Superman, Goku, and Batman. Now what if we want to delete an element at some specific index? Then for that we can make use of the delete underscore at method. So currently you can see we are having these 4 elements in our superheroes array. Let us say I want to delete the element that is sitting at index 1. So for this I can say superheroes dot delete underscore at, and then we need to specify an index at which we want to delete the element. So let me write here 1, and now let us log the superheroes to the console. So let us try this out. So now you can see Superman is gone, and now we have Spider-Man, Goku, and Batman. Now we also have shift and unshift methods, which are similar to pop and push, but they take or add elements in front of the array. So if we want to add an element in front of the array, we can make use of the unshift method. So I can say superheroes.unshift, and this adds an element to the front of the array. And then after unshift, we need to give a space and the element that we want to add at the front of the array. So here let us say Alex, and now let us print superheroes to the console and now run the file. So now you can see we first get Alex, then Spider-Man, then Goku, and then Batman. Now what if we want to remove the first element of the array? So for this we can use the shift method, removing an element from the front of the array, and let us print superheroes to the console and run the file. Okay, this should be puts. So now you can see Alex is now gone, and now we have Spider-Man, Goku, and Batman. Now what if you wanted to add something in the middle of an array? It's not a very common operation, but you can do it using the insert method. So for this we can say superheroes.insert, and at the index 2, let us say we want to insert Power Rangers. And now let us print the superheroes to the console and run the file. So now you can see first we have Spider-Man, then Goku, then Power Rangers, and then Batman. So we are successfully inserting Power Rangers at the index 2. Now let us say we want to get the size of the array, so the number of elements that are contained in it. So for this we can make use of the size method or the length method, and they both are the same. So let us say puts superheroes.size, and let me interpolate this. So double quotes, so the size of the array is this. Alternatively, we can also say the length of the array is superheroes.length. And now let us run the code. So you can see for both we are getting 4. Now let me show you the count method. So let us say we want to count how many even numbers we have in an array. So let us define an array of numbers 1, 2, 3, 4, 5. So let me define a variable count, and here let us say numbers, and on it let us apply the count method. And then as per syntax we need to specify a block. So using curly braces, then double pipe, and here let us use an alias for each of the numbers. So let us say number, and then let us give a space. So for number we need to check whether it is even or not. So let us make use of the even method, and here we can put a question mark. So here let us print to the console the count of the even numbers in the array is, and again interpolate count. So let us run the file now. So you can see it says the count of the even numbers in the array is 2, and here you can see only 2 and 4 are even and rest are odd. So this is the right output. So to sum this up, if we want to initialize an array, we can use the square brace notation. Next, if we want to read an element or access an element, we can use the index notation, the first method, the last method, to access the first and last elements of the array respectively. Next, if we want to append an element, for this we can use the push method to add an element at the end of the list, the less than operator to add an element at the end of the array again, and the unshift method to add an element at the front of the list or array. Next, if we want to remove an element, from the end of the array, we can use the pop method. To remove an element at some specific index, we can use the delete_at method. And to remove an element from the front of the array, we can use the shift method. Next, let us see how we can iterate over arrays. Now that we have got an array, wouldn't it be nice if we could enumerate its contents and print them? So we can make use of the each method. So iterating over an array. Let me first show you how to iterate over the superheroes array. So to print an array using the each method, we first need to specify the array, so superheroes, and then we use the dot notation and access the each method. Then we need to define a code block, so curly braces. Now let us use an alias for each item in our superheroes array. So let me refer this as superhero. And then for each superhero, let us print the superhero to the console. And that's it. So let us run our code. And you can see this gives us Spider-Man, Goku, Power Rangers and Batman. Now sometimes we need the index as well. In those cases, we can use the each underscore with index method. So let us iterate over the superheroes array. So each underscore with underscore index, and then we can define a code block, then use the pipe symbol. To refer to a superhero, we can use the alias superhero, and then let us use a second argument to refer to the index at which the element is sitting at. So index, and let us print to the console the superhero. So use the special string interpolation syntax and its index. And let me put a colon here, and here put the square braces superheroes. And here let us interpolate the superhero. So now let us run our file. And this gives us superheroes 0 gives us Spider-Man. Then superheroes 1 is Goku. Then we have Power Rangers and then Batman. Now most of these iteration operations are available because of the enumerable module, which is mixed into the array class by default. Now array does provide a good amount of methods too, and we will see most of them a bit later. Now let me show you how we can work with characters in a given string using the iteration techniques. Now sometimes we may need to work with individual characters, and we have two main methods to do that in Ruby, which is each underscore char and the chars method. So let us say we have a string. Alex is a software developer, and here let us say we want to print each character of this string. So we can use the each underscore char method and then use a code block right in front of this. Then we can use a alias to refer to each character of this string. So let us say character, and let us print the character to the console. So let us run the file, and you can see this gives us Alex is a software developer. Now we also have the chars method. So let me show you this. Puts, and let us place this in a separate variable. Say some string, and here we can say some string. Now here we can print some string dot chars to the console, and let us run the file. Okay, so this gives us the same output. Alex is a software developer, right? Now let us learn about a special method which is called as the map method. If you are familiar with JavaScript, the map method works exactly the same in Ruby as well, and what it does is it makes a copy of the original array, and it gives us a new array with the modified elements, which we can then assign to some separate variable. So let me first print the superheroes array to the console. Okay, so here are our superheroes. So for this we can say superheroes dot map. So on the superheroes array we can use the map method and then define a code block, and for each superhero let us convert the superhero to uppercase, so uppercase like this, and this map method will give us a new array. So let us set this back to the superheroes variable itself. And now let us print the superheroes array to the console. So let us run the file, and you can see now we are getting a capitalized version of these 4 elements. Now we also have another method that I want to cover in this video, which is the select method. So let us say we want to find all the numbers that are odd using the select method. So for this we can say numbers dot select and then use the code block, and for each number we want to check for the condition number modulo 2 equals 1. So let us print this to the console and run the file. Okay, so this gives us 1, 3 and 5, because in the given array we are having 3 odd elements which are 1, 3 and 5, right? So selecting odd numbers. Now let us see more array operations. Now there are a lot of things that we can do using arrays, like sorting, reversing, or picking some random element. So let us see how the sort method works. So let us say we are given an array of some numbers and they are not in ascending or descending order, so they are distributed randomly. Now if we want to sort the numbers in ascending order, we can say some numbers dot sort like this, and let me store this in the sum numbers variable itself. And now let us print this to the console and give this a world. Okay, so this gives us 1, 2, 3, 3.4 and then 4 and 5. So sorting the numbers in ascending order. Now we can also remove duplicate elements from an array. So for this, let us see a method which is called as the unique method. So consider this array duplicates 1, 3, 3, 4, 5, 4, 1. Now we can remove the duplicates from this array using one single method, which is the unique method dot unique. And let me set this to a variable uniques. So now let us print the uniques to the console and run the file. And you can see now we are getting 1, 3, 4 and 5. Now let us say we want to pick some random element from the given array. So for this we can use the sample method. So let us use this numbers array that is given to us and pick some random element from it. So puts numbers dot sample. So let us run our file, and this gives us 4. Let me again run this. Now it gives 3. Now let us say we want to slice our array, so basically extracting a portion of our array instead of the entire array. So for this we can make use of the take method or the slice method. So let us see an example for both. Let us say we want the first 3 numbers. So for this let us create a new variable first 3 and numbers dot take, and here we need to specify the number of elements that we want. So we want to take the first 3 elements from the array, and now let us print first 3 to the console and run the file. So we get 1, 2 and 3. Now for slicing we don't have any slice method, but what we can do is we can use the square brace notation and specify 2 indices. So one is the starting index and the other one is the end index. So the starting index is inclusive and the end index is exclusive. So this will give us the first 3 elements starting from index 0 and goes on till index 2. So here again let us say first 3, and let us print this to the console and now run the file, and you can see this also gives us 1, 2, 3. Next let us move forward and understand the splat operator in Ruby. So the splat operator can be used on the left hand side of a variable assignment. The variable name with the splat, or you can say the asterisk, will try to grab as many values as possible and then wrap them in an array. So here let us say A and then B, A comma B, and set this to 1, 2, 3, 4, 5, And now let us print A to the console. So use the string interpolation syntax and B to the console. So now let us run the file, and you can see we get an array for the variable A, and for variable B we get 5. So in essence, a variable with this splat operator or the asterisk, it is trying to grab as many elements as possible while still leaving one element to other variable. So here if you see, B is given this 5, and then if you have an asterisk on a variable, then it collects all the variables but not 5, because 5 is given to B. Make sense? Now let us see the concat method in action. So let us say we are given two arrays and we want to concat them or join them using the concat method. So here let us say even numbers 2, 4, and then let us say odd numbers 1 and 3, and let us say we want to concat these two arrays. So for this we can use our concat method. So first 4 even numbers dot concat, and to this concat method we need to pass the other array, which is our odd numbers. And now let us print the first 4 variable and run the file, and this gives us 2, 4, and then it concats 1 and 3 to give this array 2, 4, 1, 3. Now what if we want to extract one array from another? In that case we can make use of the minus operator. Now let us say we want to get the elements that appear in both the arrays at the same time. For this we can use the AND operator. So let us say puts A and B and run the file, and you can see this gives us a type error, and the reason for this is that this A variable is an array but the B variable is not an array, it's a number, so there is no implicit conversion of this integer into an array. Make sense? Now there is one thing that I want to show you right here. What happens in the concat method is that the even numbers array gets mutated right after this operation. So if I print the even numbers to the console, it will also contain these two numbers 1 and 3. So let us run the file, and you can see it is also having 1 and 3. So concat method mutates the original array as well on which it gets applied. So our even numbers is 2, 4, 1, 3, and the odd numbers variable is 1, 3. Of course this is not correct, but it is because of this concat method that it mutates the original array, which is having 2, 4 in the start, but now it also contains 1 and 3. Make sense? So let us try finding the intersection of these two arrays. So for this we can use the AND method. So here let us say puts the common elements are numbers and odd numbers. So let us run the file, and this gives us 1 and 3. So 1 and 3. So 1 and 3 are common elements between these two arrays. Next, if we want to find the union of the given arrays such that the duplicate elements are also handled, then for that we can make use of the pipe symbol. So puts, and this should be not method but operator, and same for this as well. The union is even numbers and pipe odd numbers. So let us run the file. So the union is 2, 4, 1, 3, and now let us try finding the union for the duplicates and some numbers array. So puts duplicates and use the pipe symbol some numbers, and let us give this a whirl. Okay, so we get 1, 3, 4, 5, 2 and 3.4, and the duplicates are also eliminated as you can see in the output. So now let us proceed further and learn about hash tables in Ruby. Now hash tables are kind of a map that help us in storing the key value pairs. So each key is mapped to some value. So you can think of them as a dictionary where you can look up a word in the dictionary and that word has some associated definition. So in Ruby, the hash class lets you create the new hash objects. So the keys of the map or the hash table can be anything including strings, symbols, and numbers. So let us first see some basic usage of the hash tables. So creating a hash table. So let us create an empty hash table and let's name it as items. So to define a hash table, we need to use the curly braces like this. And now to add a value pertaining to some key, we can use this syntax. So items, and then to define a key, we first say colon and the item name. So let us say pen, and set the value as the quantity of the pens that we are having. So let us say 2. Then let us add another key, items, and let us say pencil, set this to 5. Items, let us add another key, laptop, set this to 6. Okay, so let us remove these semicolons. Now to access the value pertaining to a specific key, we can use the same syntax but without this equal sign. So for this we can say puts the quantity of pens are items colon pen, the quantity of the pencils are items colon pencil, and finally the quantity of the laptops are items colon laptop. Now as a side note, you need to remember that the keys of a hash table are always unique. This means that you can have only one pen key, one pencil key, and one laptop key, and no more. Make sense? So let us run the file now, and this gives us the quantity of pens are 2, the quantity of the pencils are 5, and the quantity of laptops are 6. Now let us see how we can iterate over the hash tables. So it can be very useful to iterate over the hash values and keys. So again, we can make use of the each method that we learned in the arrays section. So let us first log the items hash table to the console. Current items, and let us run the file. Okay, so this is our hash table. So pen maps to a value of 2, pencil maps to a value of 5, and laptop maps to a value of 6. So let us print each key value pair. So for this we can say items dot and then use the each method and then give a space, use the keyword do. Then for each key value we can use the double pipe symbols, and here we can say key and value, or we can also say this as item and its quantity, and then put a colon, and then go to the next line, and here let us say item and then put a colon quantity. And then right after this we can end. So let us run the file now, and you can see it gives us pen colon 2, pencil colon 5, and laptop colon 6. Now as a side note, if you only want to iterate over the values of the map, then we can make use of the each underscore value method. And if you want to iterate over the keys of the hash table, then we can make use of the each underscore key method. Each underscore key and each underscore value. So let me show you this real quick. Let me copy this and paste it down below 2 times. And here let us use each underscore key. And here we are only interested in item. And for the each underscore value method, we are only interested in the value pertaining to a key value pair. So let us run the file now. Okay, so we get pen, pencil, and laptop for this one, and for this one we get all the values 2, 5, and 6. Next, if we want to get the array of the keys that we have in our hash table, we can use the keys method, and if we want to get the values of our hash table, we can use the values method. So here let me print items.keys, and here let us print items.values. dot values. So let us run the file. So the keys array is pen, pencil and laptop, and the values array is 2, 5 and 6. Now what if we want to check whether a key exists in the hash table or not? So for this we can use the key question mark method. So let us check whether we do have the pen key in our items hash table. So let me use the interpolation syntax, items dot key question mark, and then use the parenthesis and check for pencil. And let me copy this and paste it down below, and now check for tab. So let us run the file now. So for this we are getting true because the pencil key exists in our hash table, but for the tab key we don't have any entry in our hash table, so we get false. Make sense? Let us say we want to count the occurrences for each of the characters that are there in a given string. So let us say the given string is the nerdy dev, and for this string we want to count the occurrences for each of the characters. So for this let us use a hash table. So frequency hash table, and set this to a curly brace. So this is our initialization. Now the very first step is to iterate over the given string and check for the presence of the character that we are currently on in a particular iteration, that whether that particular character is present in the hash table or not. So the process here is that we need to first iterate over the given string, and for each character we need to check whether it is there in the hash table or not. If it is already present as a key in our hash table, then we need to update its frequency by 1. Else if it is occurring for the very first time and it is not present in our hash table, then we mark its presence by setting it to 1. Make sense? So for this we can say given string and apply the each method, or more specifically as we discussed just a while back, each underscore char method, and do. And then for each character we need to check whether this particular character is already present as a key in our hash table. So frequency hash table dot key question mark, and here we need to check for the character. So if this is the case, then we can say frequency underscore hash table, and then for the value that pertains to this particular character in our hash table, we need to increment it by 1. So the value gets incremented by 1. Else if it is occurring for the very first time, then we can say frequency hash table character and set this to 1. And then here we can end the if block and then end the outer block. So now let us print our hash table to the console. Frequency hash table and run the file. Okay, so you can see for T we are getting 1, for H we are getting 1, for E we are getting 3, for N1, R1, D is 2, 5 is 1, and V is also 1. Now let us say we only want to print those keys for which we have frequency 1. Okay, so this is another exercise that I'm giving you. So feel free to try this on your own. So let us give this a whirl now. So here I can say frequency underscore hash table dot each, and then use the do keyword. Then for each key and value, if the value is 1, then let us print the key to the console, and here let us end the if block and then the outer block. Okay, this should be K. So let us run the file now. We don't need any colon here. Run now. Okay, so we are getting T, H, N, R, Y and V. So this code that we did as an exercise is very simple, and what we are doing is we are counting the occurrences of each of these characters that we are having in this given string, and we are storing the result inside a hash table that is recording the frequency of each of these characters. And here you can see we are checking for the key and we initialize it to 1 if it does not exist in our hash table. Now if we don't place this check right here, then we will get an error. So this is it for the basics of the hash table. Let us move further and understand the fetch and merge methods in context of the hash tables. So fetch and merge methods. So let us say if you are trying to query for a hash, so for a key that does not exist, then in that case, what will you get? So let me add a hash table and set this to an empty curly braces. And here let us print and try to access some invalid key. So hash table colon something random, and let us run the file. Okay, so we are getting nothing, as you can see. So this does not give us some meaningful error, right? So what happens here is that the hash table is trying to find a hash for this key which does not exist in the hash table. So it gives us a blank thing, right? So to get some meaningful or more useful error, we can use the fetch method. So here let us say puts and use the string interpolation syntax hash table and dot the fetch method, and let us try to fetch the value pertaining to some invalid key. So again let us say something random and now run the file. Okay, so now we are getting a meaningful message which is a key error which says key not found something random. Now we can use the fetch method to give a default value for something that does not exist. So we can use fetch with a default value, and this won't set a permanent default or create a new key in the hash. So here we can say default or say invalid and then run the file. Okay, so for this we are getting invalid. So now let us proceed further and let us see how we can merge two hashes. So merging two hash tables. So another interesting method that we can make use of in the hash tables is the merge method. So this method lets us merge two hash objects. So if a value already exists in a hash table, then it will get overwritten by the new one, and this method then returns us a new hash. So let me show you the example for this. So user and set this to a map. So name as Alex, age as 21, profession developer, and then here let us call the merge method on this and add a new age of say 41 and country as UK. So now let us print the user map or user hash table to the console and run the file. Okay, so this should be a map itself like this. Again try this out. Okay, so this is our original hash table, and now this merge method returns us a new hash table. So let us say new user and then print that to the console right here. New hash table, new underscore user, and then run the file. Okay, so now we are getting name as Alex. Now right after the merge, age got overwritten to 41, profession is still the same, developer, country UK. So these two hash tables got merged using this merge method, and the key of age got overwritten from 21 to 41. And then this merge method returned us a new map or a new hash table that we stored right here, and this is what gets logged right here. So now let us proceed further and learn about the dig method in Ruby. So if you want to traverse a hash which has more hashes nested within it, something that is common with JSON, then you could do something like this. So here let us first create a hash table person and set this to curly braces. Then let us create another one nested within it, details, and here let us say name Alex, gender male, profession developer, and age 21. So let us use the older way to access the gender property So for this we can say puts person. Then on this we can call the fetch method, and we want to fetch the details, and then let us call another fetch on this. And now we are interested in accessing the name. So let us run the file. Okay, so this should be a colon. Okay, so we are getting an error. Let's remove this space and now run the file. Okay, so now we are getting Alex in the console. Now let us assume for some reason that the details key does not exist. What would happen is that you would get an exception even if you use the square brace syntax to access the keys. Now in order to solve this problem, we can make use of the dig method. So if any of the keys do not exist, then we will get null. So let me demonstrate this. So puts, if here we say person, and here we try to access the name property again on the details hash table, and then name. So let us run the file to see what we get. Okay, so we get Alex. Now let us try to access a key that does not exist on the details hash table. So puts person.dig details, and let us try to access some invalid key, anything say, and now run the file. Okay, so we are getting nothing. So if a particular key does not exist on the hash table, then we get null. Make sense? Now let us see another method in action, which is the transform values. So if we want to change all the values in a hash table, then we have a new transform values method which we can use to change the values for the keys that we have in a hash table. Let us say we want to change the quantity of the items that we are having in the hash table. So let us first log the items hash table to the console. Okay, so here it is. Pen is 2, pencil is 5, and laptop is 6. So now let us apply the transform values method on our items hash table, and then use a code block. Now for each value, I want to change the value to twice of what it currently is. So this should give us pen as 4, pencil as 10, and laptop as 12. So let us set this back to items variable. Let us log it to the console and run the file. So pen is now 4, pencil is 10, and laptop is 12. So let us now wrap up with the hash tables topic, and let us proceed further to the topic of sets. Now a set is a class in Ruby that helps you to create a list or a collection of unique items. So let us see an example for this. So let us understand the use case in which you can use sets. Let us say we have some duplicated entries in a list and we only want the unique ones. Then if we want to find the unique ones, we can put all those entries in a set, and the set will make sure that the result that we get back contains only the unique entries and not the duplicates. Make sense? So let us first see how we can work with sets. So first we need to require the set, and then here to create a set, let us say numbers and set this to set class. On this we have the new method like this. Let us add a couple of numbers to the numbers set. So numbers, let us use the less than symbol and add 1 to it. Numbers less than 2, and numbers less than 3. Let us again add 2 to this, and now let us print the numbers to the console. So let us run the file now. Okay, so we are getting a set, and you can see each entry is occurring only once. So 1, 2, and 3, right? So no duplicates at all. Now another benefit of using a set is that the search operation is going to be very fast. So if I say numbers dot, and let us use the include method, and let us try to search for 1 and run the file. So it says true because 1 does exist in the numbers set. Okay, so this was a brief introduction to sets. Let us proceed further to the next topic, which is ranges. What are ranges? Ranges let us define intervals of characters, numbers, and say time. So they are very useful if you need something like all the letters of the English alphabet, or say a list of numbers that lie in a particular interval. Now, an interesting thing is that the range includes enumerable, so you can use ranges to iterate without having to convert them to an array first. So if you still need an array, you can call the to_a method on the range. So let us see an example for a range. So if I say from A and then to Z, and here if I call to_a method to transform this range into an array. So let me log this to the console and run the file. So you can see this gives us all the characters of the English alphabet from A to Z. So this is a nice shortcut if you want all the characters starting from small a to small z. So let us say we want all the numbers ranging from 1 to 10. So for this we can say puts and then use double quotes, the string interpolation syntax 1 dot dot and 10, and then on it let us chain our to_a method. So now let us run the file, and this gives us an array of numbers starting from 1 until the number 10. Now let us see the step method in action. So if we want a certain step size or our numbers following a certain step, so let us say if I want numbers from 1 to 10 with a step size of 2, so that we skip. So for this we can say puts and then use the string interpolation syntax. So first we need to specify the range, and then let us apply the step method on this. So I want a step size of 2 and then chain the to_a method on this. So let us run the file. So this gives us 1, then we get 3 and then 5, 7 and 9. So this gives us numbers in step size of 2 starting from 1 till 10. So we get 1, 3, 5, 7 and 9. Next let us say we want to iterate over a range. So let us say we want to iterate over a range of numbers from 1 to 10. So for this we can say 1 dot dot and till 10, and then apply the each method on this and then a code block. And for each number let us print the number to the console and let us give this a whirl. So this gives us 1, 2, 3 till 10. Now what if we want to get a random number in a specific range? So let us say I want to get a random number in range 1 to 10. So for this we can say random number equals and call the random method, and here I can pass the range from 1 to 10, and now let us print the random number to the console. So the random number is random number. So let us run the file. So we get random number as 6. If I again run this, then we get 5. Now let us proceed to the next topic, which is data serialization. Now data serialization is the process of converting the in-memory data structures into a format that is suitable for transmission over the network or over the wire. So the serialization formats can be classified into two groups. So the first one is the plain text and the second one is the binary format. So the binary formats are usually more efficient because they have the advantage of being human readable. So in this lesson we are going to cover some popular plain text formats. So the formats that we are going to cover are CSV and JSON. Let us first understand about the CSV format. So the CSV format stands for comma separated values. So it is the simplest format of the serialization that you will use. Now as we know, a CSV table is kind of composed of a number of rows and each row is composed of certain number of columns. So the datasets that you see over the web are composed of CSV values, and the document is represented as a CSV file. So a CSV document is composed of multiple rows, and each row comprises of a bunch of values that are separated by commas. So in Ruby we have access to a built-in CSV class that will allow us to easily work with CSV documents. So let's first require it, just like we did for set. So require CSV. Now in order to demo this, let me create a new CSV file, items.csv, and here let us say id, item name, and quantity. Then on the next row we again need to specify a couple of values separated by commas. So now we need the value for id, and the item name, let us say pencil, quantity is 2, then pen 3, and then laptop 6. So back to our main.rb file right here. Let us read our CSV file. So for this we can say puts CSV, and on it we have the read method, and here let us say the file that we want to read is items.csv. So let us run the file. So this is what we get: id, item name, quantity 1, pencil 2, 2 pen and 3, and 3 laptop 6. So currently you can see it is omitting the headers, but if we want to include the headers, then we can pass a second argument, and here we can say headers colon true. Now this should now give us the header as well. So let us run the file. Okay, so now we are getting the header row as well, and then our items. So now let us proceed further with the next serialization format, which is JSON. JSON stands for JavaScript Object Notation, and it is the format for interchange of data over the wire. Now the JSON format might remind you of the Ruby hash tables, with the difference that the keys of a JSON object are always strings. Now like the other formats, Ruby also has a built-in class to deal with JSON. So let us see how we can read a JSON string and convert that to a Ruby hash for easy manipulation. So let us first import JSON, and then let us create a JSON object. Now here we again need to use the curly braces, but we need to wrap this within quotes. Now here let us specify the key within quotes. So let us say pen and give this a value of 300, pencil, give this a value of 400, laptop, give this a value of 600. Now let us convert this JSON string into a Ruby hash table. So for this we can say JSON dot parse, and to this parse method we need to pass the JSON object. Let us set this to a variable and let's name it as hash. So let us print the hash to the console and run the file. So this is what we get as the output. Now to convert this hash back to JSON, we can make use of the toJSON method. So let us say hash dot to_JSON, and now let us run the file. Okay, so now we are getting the JSON representation of the hash that we got on line 420. So now let us proceed further and understand the concept of classes in Ruby. Now class, as we know, is a blueprint using which we can create objects. So a blueprint is kind of a template that specifies the attributes of a particular thing or a real world entity that we are trying to model. So let us say we are trying to model a vehicle. It comprises of wheels, then it has a fuel or gas tank capacity, it also has horsepower, it has a model. Now these characteristics or properties, or what we call as attributes, form the data members of the class vehicle. Now this is what is used to differentiate one vehicle from the other with the help of these attributes. Make sense? Now a vehicle can also have certain methods, like it can stop, it can accelerate, it can speed up. So kind of these methods also form the data members of the class vehicle, and therefore you can say a class is a blueprint that wraps all these attributes and methods. Make sense? Now as we know that the Ruby has been designed as an object-oriented programming language from the ground up, unlike many other programming languages where OOP is just an extra feature. Now everything in Ruby is an object, just like we have in JavaScript. So all the classes in Ruby inherit from the object class by default, and the object inherits from the basic object class. So let me write this down here. All classes in Ruby inherit from the object class, and then the object class itself inherits from the basic object class. Make sense? Now this object class also includes our kernel module, which is where many useful methods like puts that we were using before comes from. Now before we define a class, let me show you one thing. Now this thing, which is a JSON object, has its own class. So let me demonstrate this. JSON object dot class and run the file. Okay, so this gives us a string, because essentially this is a string, a JSON string. And then if I say hash dot class and run the file, this gives us hash, right? So right after parsing this JSON, we got a hash, and this hash, the variable, is of data type hash, and this hash is the class. Make sense? Now if I say hash dot class and then run the file, this gives us class. Now the next thing is that classes are objects too. So in fact they are instances of a class known as class. So if I say puts array dot class and then I puts string dot class, puts hash dot class, puts integer dot class. So let us run the file, and now you can see each of these classes are themselves instances of the class. Make sense? Now before we learn more advanced stuff about classes, let us see how we can create a basic class used in Ruby. Now to implement or incorporate object-oriented programming into Ruby, we need to learn how we can create objects and classes in Ruby. So a class in Ruby always starts with the keyword class followed by the name of the class. So let us say customer. Now the name should always be in capitals, so the first letter should be capital. So this entire name should be in capital case, and then right within this we can define our attributes and methods. So we terminate a class by using the end keyword. So all the data members in the class are between this class definition and our end keyword. Make sense? Now before we define the methods and attributes in our customer class, let us see how we can define our own methods. So let me go right here and talk about methods. Now the methods in Ruby are very similar to functions that we have in other programming languages. Now to define a method in Ruby, we need to use the def keyword followed by the method name. So let us say greet. And then we need to use a pair of parentheses. And to end the function definition, we can use the end keyword. Now within this, let us define the definition for our greet function. So here let us log to the console, good morning. So this is a very simple method in Ruby. So let us call this. Now in order to call it, we just need to reference the method name followed by the invocation parenthesis. So let us run the file. So this gives us good morning. Next, let us see how we can define a method that accepts arguments or parameters. So let us say we want a function that adds two numbers. So this function takes two numbers as arguments. So number 1 and number 2. And then it performs an addition of these two numbers and returns the result. So number 1 plus number 2. And here let us add the end keyword. Let us call our function 2, 3 and store the returned value in a result variable. So let us print the result. The addition of 2 and 3 gives. result. So let us run the file. So this gives us 5. Now this return statement can also be used to return one or more values from the method, but here we are just returning the sum of these two numbers that we are receiving as arguments. Make sense? Now let us go back to our class definition, and within it let us define an attribute, so customer count. Now this should be a class variable. So the class variables are something that are available across the different objects. So a class variable belongs to a particular class, and it is the characteristic of a class. Now to define one, we need to use the double at symbol followed by the variable name. So let us give it an initial value of 0. Then we also have instance variables that are available across methods for any particular instance, or that are bound to an instance or the object. That means that these instance variables differ from one object to another. And to define an instance variable, we just need to use a single at followed by the variable name. Make sense? Now next, let us see how we can create new objects in Ruby. So to generate new objects based on this blueprint that we define within the customer class, we need to define a constructor function. And to define a constructor function, we need to declare a new method with some parameters. So this special method is known as initialize. And this runs at the time of object creation. So this is a very special type of method which gets executed when a new instance based on this blueprint gets created. So here let us take a variable ID, name, age, type, and gender. So next we need to define the instance variables or the properties for the new object or the new customer that we create based on this class. So to define the properties for the instance, we can make use of the at symbol followed by the property name. So at ID and set this to ID, then at name, set this to name, at age, set this to age, and then at type, set this to type, at gender, set this to gender, and then we need to end this method. So here we are declaring the initialize method with the ID, name, age, type, and gender as local variables. So now let us see how we can create objects in Ruby. So objects, as we know, are instances of a class. So to create an object in Ruby, we can make use of the new method which comes built in the Ruby library, and this belongs to the class methods of Ruby. So let us create the first customer, so customer 1, and on the customer class we can use the new method like this. Now we need to pass the arguments to this. So first we need to give an ID 1, name say Alex, age 21, type high spender, gender male. Customer 2, customer.new, to James 29, type is say low spender, and gender is male. So to create a new instance based on the customer class, we need to use the class name followed by the dot notation and then the method which is new, and then we pass the arguments or the values for the properties that we want on a customer, so which are ID, name, age, type, and gender, and this creates a new object for us based on these properties. So this gives us two instances of customers. Now let us say on creation of each customer, we need to increment this customer count variable, the class variable, by 1. So let us go right inside the constructor and say at customer count plus equals 1. So this essentially means that take the old customer count value and add 1 to it. So currently you can see it is stuck at 0, and the count of the customers should go up as soon as a new customer gets created or initialized, which is because of this increment statement. Next, in order to see the customer count, let us define a class method. So to define a class method, go right here and use the def keyword, and then on the entire class, which we can reference using the self keyword. So this self refers to the entire class and not to the instance of the class. So on this self, we can use the class method name. So let us name this as count. And right inside this method, let us say at customer count and end this. So in this case, we are inside the scope of the class only and not within the scope of an instance. So now, right before creating our customers, let us say current count of customers and use the string interpolation syntax customer dot count. And let me copy this and paste it down below after creation. So now let us run the file, and this gives us current count of customers. So before the creation of our 2 customers was 0, and right after creation of the 2 customers, it got incremented by 2. So 1 for each. So this gives us current count of customers after creation as 2. Now right within the customer class, let us define a new method. So display customer details. And here what we need to do is, we need to do a couple of logs. So customer ID hash, and then the @ symbol to refer to the instance variable ID, puts customer age hash, and then @age, puts customer name hash @name. Let me place this right here, customer type, and then customer gender. And then here use the end keyword like this. Now let us call our methods. So customer1 dot display customer details and customer2 dot display customer details. So let us run the file now. Okay, so we don't need a colon here. So here are the results. Now these instance variables are by default private. So what if you want to access them? So if you want to access them, you have to be explicit about it. So for this, we can make use of a concept called as attribute accessors. So if you want to access the data that we are initializing right inside our constructor function, which is known as initialize in Ruby, then in that case, you would need to set up an attribute accessor. So let us see how we can set up an attribute accessor. So let us go right inside our class, and here let us set up a attribute reader. So to set up an attribute reader, so what this attribute reader gives us is that we can access or read the value of our instance variables for a object that we are modeling. So let us see the first attribute accessor, which is our reader. Now what this does is that it helps us in looking into our object and derive or extract the data that we want from our instance that we are defining within our class. So here I can say I want access to the properties ID, name, age, type, gender. So kind of this allows the outside world to look into our object and get access to the data that they want. So if I now say right down below here and say customer1.id, and let us print that to the console, and then say customer1.name, then customer1.age, customer1.gender, and let us run our file. Okay, so you can see we are getting 1, Alex, 21 and male. So using the @reader, we can give access to our instance variables to the outside world right here. So right outside the class definition. Now we have something called as @writer and @accessor. So if you want to perform only the write, then you can make use of the @writer. And if you want to perform both read and write, then you can make use of the @accessor. So let us set up a @accessor for our type property. So let me go right here and say at our accessor and just on the type property. And here you can see that for customer 2, the type property is set to low spender. Let us change it to high spender. So for this, now I can say customer 2 dot, and I can directly access the type property on the customer 2 object and change this to high spender. And now if I print the customer 2 dot display customer details to the console and run the file, now you can see for customer 2 we are having the customer type as high spender. Make sense? Now this as a general rule is a bad practice because we want to minimize the access, the outside access to these instance variables. So if you just want to read the instance variables, use @reader and not the @accessor. Make sense? Now let us proceed further and learn about the 3 levels of protection that we have in Ruby. So at the instance methods level, we have 3 levels of protection. So we have the public access control, private access control, and the protected access control. Now Ruby does not apply any access control on the instance and class variables, but it does apply these controls on the instance methods. So let's first talk about the public methods. Now these are the methods that can be called by anyone, so anyone out in the outside world. So these methods are public by default, except for this initialize method, which is always private. Next, let us talk about private methods. So these cannot be accessed from outside the class. Only the class methods can access the private members, right? Next, we have the protected methods. And a protected method. So a protected method is a method that can only be invoked by the instances of the class in which it is defined in and all its subclasses. So let me demonstrate all these 3 controls by taking an example. So let us first define a class and let's name it as cube. So here first let us set up our constructor method. So initialize, and this will take on a single argument which is side, and here we will set the side like this, and here let us end. Then right next to this let us define a method area, and here let us calculate the area of the cube. So for this we can say return 6 into side square. Next let us define our get volume method, and this will return side cube, so side times side times side. And now let us make these methods as private, so get area and get volume. Next let us define our print area method, and what it does is it simply calls the get area function like this and then prints that to the console. The area of the cube is area. Then similarly, let me copy this and paste it down below and name this as print volume get volume, and this as volume. So the volume of the cube is volume, and let us place end here for each of these methods, and for this as well. Now let us mark our print area and the print volume methods as protected. So colon print area and print volume. And now let us end our class definition like this. So let us first create a new instance of our cube class. So instantiation. So cube1 cube.new, and to this let us pass an argument which is the side. So let us pass as 4. Now let us first try calling the getArea method on our cube1 instance, and let us run the file. Okay, so we don't need colons here. Let me run it again. Save for this one. Okay, so we are getting an error now. It says private method getArea called for this, so no method error. Now here, if you can see, we are trying to access a private method from outside our class, and this doesn't work. But if I call the printArea method instead and then run the file, you can see we get an error, right? And this is because we are trying to access a protected method. So in order to make this work, what we need to do is we need to allow the access of these methods on our instances. So let me remove this line and now call the function. Okay, so now you can see we are getting the area of the cube is 96, right? So what happens here is that for the cube1 instance, we are running the printArea method. This computes the area by calling the getArea function. It stores the returned area inside the area variable and then prints the area of the cube is 96, right? Now this, as you can see, this method that we are calling on the instance relies on a private method which is getArea. Now similarly, we can call the printVolume method, so puts. Now here we don't need to use puts here, we can just call it because we are not returning anything from these methods. So here I can say cube1 dot print volume and let us run the file. Okay, so now we are getting the volume of the cube is 64. So we are passing 4 to our cube1's side, and then we call the printVolume method. Then we call the private method getVolume. It internally gives us the volume by computing side into side into side, returns that, stores the returned result right here on line 528, and then prints the volume of the cube. So now let us proceed further and talk about the concept of inheritance in Ruby. Now one of the most important concepts of any programming language that is based on object-oriented programming is inheritance, right? So this allows us to define a class based on another class, so we basically can inherit the properties from kind of some super class. So by this concept we can inherit the properties of a class, and we can define a class in terms of a parent class or in terms of the properties that we derive from some class. And this makes it easier to create and maintain any application. So with inheritance, we can inherit or reuse the code functionality by basically inheriting the data from an existing class. The existing class is called as a base class or a super class, and the new class that is derived from that existing class is called as the derived class or subclass. So Ruby uses this concept of subclassing, or you can say inheritance. So let me demonstrate the concept by taking an example. So let us say we have a class A, and here let us define a method do something, and here let us say doing something. Then here let us say walk the dog, and then print to the console walking with the dog. And let us end this class definition right here. Next, let us add our subclass which inherits from this existing class, so A. So this character represents that this class B is inheriting from the class A. So this class or the instance based on this class will receive these two methods in inheritance, and on top of that it will also have the methods that I'm going to define right now. Do that, doing that, sing song, singing the song. Okay, so let me place the end here. So let us quickly create a new instance for our B class, so b.new, and now on this instance we can call the method that we have defined in our A class. So we can say b dot do something. So let us give this a whirl. Okay, so we don't need the colon here and here also. Okay, so you can see it is logging, doing something to the console. So what happens at this instance, that is based on the blueprint that we have defined within our B class, is also inheriting the properties and methods that are defined in the A class. So this gives us a handle to access any of these methods with the B instance. So if I say b dot walk the dog and b dot do that, these all should work, right? So you can see it logs doing something, walking with the dog, doing that. So this is it that I wanted to cover about inheritance. Now let us proceed further and learn about the concept of procs and lambdas. So in this section, first we will understand about Ruby blocks, then we will talk about the yield keyword, and then we will talk about lambdas and the difference between lambdas and procs, closures. So let's get started. So first let me briefly discuss about the Ruby blocks. So previously we discussed about the ways to iterate over an array, so using the each method, and then we define a Ruby code block. Then for each number we print the number to the console. So let us run the file. So here you can see we are getting 1, 2, 3. So as you can see, this each method takes on a Ruby code block, and these are little anonymous functions, so a function that has no name, and we can pass these functions into our methods. So for this case it is the each method to which we are passing this anonymous function or the Ruby block. Now this is mostly the recommended way when you are using a single line block. Now what if you want to write this in form of a multi-line block? Then in that case you would need to make use of the do keyword and then print the number on the next line, and then right here you need to use the end keyword. So the blocks are enclosed in a do end statement or in between these brackets or the curly braces, and they can have multiple arguments. In this case we are having only one, which is the number. Now previously we also discussed that the argument is defined between the two pipe characters. So this is what a block is. Now let us proceed further and learn about the yield keyword in Ruby. Now using the yield keyword, we can pass a set of additional instructions to our code block. Now when you call yield inside a method, then yield will allow us to inject code at some place that we want. Now whenever you want to incorporate within a block some set of additional instructions from outside, then you can make use of the yield keyword. So you call the yield inside a method, and that method is usually defined in some code block. So a block, as we know, is simply a set of statements that it holds, and yield will allow us to inject some code at the place where we are using the yield keyword, right? So let us take a very simple example to understand the yield keyword when used inside the body of some method. So let us say A, and within this let us say inside A, and then here let us say yield, and then puts coming out of A. Now what we can do is we can call the A method, and to it we can pass some additional instructions. So here let us say puts hello from outside of A, and here let me place end. So let us run our file. Okay, so you can see inside A, then comes the yield keyword, which kind of serves as a placeholder inside which we inject this content. So hello from outside of A, and then we move to the third one, which is coming out of A. So first this runs, then this serves as a checkpoint. So here we interpolate this content, and then we move to the third statement, which says coming out of A. Now let me show you another example. So if I say def perform operation, and here let us say first we want to perform 2 into 3, and here I'm using the yield keyword. Then right next here let us say inside perform operation, and then let us yield 5 divided by 6, and then end right here. Now here to pass some additional instructions, we just have to say perform operation. Now when we call it right here, it knows that this method uses the yield keywords. So on line 584 and 586. Then here next to this, we can pass some additional instructions. So use a code block or a Ruby block and say number. So whatever we get as a result of this operation, we pass that to this puts statement where we print the result. So number. So let us run our code. So you can see first we get 2 into 3, which gives us 6, and this 6 gets yielded from the perform operation method or function. The 6 gets received right here and gets logged to the console. Then we log inside perform operation, and then we again encounter a yield statement. 5 by 6 gives us a fractional value that gets reduced or that gets rounded down to 0. Then 0 gets logged. So 6 inside perform operation and 0 gets logged to the console. So to sum it up, yield is a Ruby keyword that calls a block when you use it, right? And this is how methods use blocks. So when you use the yield keyword, which we are doing right here, the code inside the block will run and do its work, just like when you call a regular Ruby method. So whatever block that we pass to our perform operation function will get printed on our console. So this is the block that we are passing as an additional instruction, and this receives 2 and 3. So prints 6 to the console. Then we move to the second line inside perform operation, and then the result of this is passed to this, and as a result we get this as our output. So here we are calling our block, which is this block, multiple times. So first time we are calling it right here, and second time we are calling it right here. So let me give you one more example. So print 2 times, and here I can say yield, and then end here. And here we'll first call our print 2 times method, and we can pass additional instructions. So what we want to print 2 times, or what we want to inject on lines 593 and 594. So let us say puts hello world. So now if I run the file, you can see we are getting hello world 2 times. So this block is getting executed 2 times within our print 2 times method, because here we are having 2 yield keywords. If I place one more right here and then run the file, we will get this being executed 3 times. So you can see we are getting 3 logs. Okay, now let us proceed further and learn about the concept of lambdas. So lambda, kind of, if you are familiar with Python programming language, then you must be knowing about the concept of lambdas. So lambda is a way to define a code block along with its parameter with some very special syntax. So you can save a lambda into some variable and you can use it later as and when you want. So the syntax of defining a lambda looks something like this. So first we define some variable. So let us say first. And set this to a lambda. So to define a lambda, we first use a hyphen, then a greater than symbol. So this arrow symbol you can say, and then we define a block. So let us put a log here. So puts this is a lambda. Now defining this lambda alone won't run the code that we are having right inside it. Just like defining a method won't run the method, we need to make use of the call method to execute this lambda. So right here we can say first dot call like this. So let us run the file, and you can see this gives us this is a lambda. Now there are other methods as well using which you can call a lambda, but we recommend that you stick with the call method for clarity. So you can call a lambda by saying first dot call and then use the invocation parenthesis, or you can say first dot and then the invocation parentheses, or first and the square braces, or you can even say first dot triple equals. So let us run the file, and you can see for each of these 5 invocations we are getting this is a lambda. Now lambdas can also optionally take arguments. So let us see an example for this. So let us say multiply by 3. And to define it as a lambda, first we need to use the equal sign. To the left we are having a variable, and then say a hyphen and the greater than sign, and then we need to receive some argument. So to receive an argument, we say opening parentheses and the closing parentheses, within which we can define the argument name. So let us say num, and then define a Ruby block, and here let us say num times 2. So now to this multiply by 2 function, let us pass a number so that it can multiply that number with 2 and return us the result. So for this, let us call this out. So puts multiply by 2 dot call, and to the call we need to pass an argument. So let us use our invocation parentheses and pass 4 and run the file, and this gives us 8 as the result. So now let us proceed further and learn about procs in Ruby. So procs, also known as closures or lambdas, that we'll see a bit later, is a concept in Ruby that may seem confusing at the start, especially to a newbie. So in short, procs allow us to pass code blocks just like we were doing in the case of yield keyword. So we can pass code blocks around with ease using a procs. So let us see an example. Let us define a variable first and name it as result, and define a proc. So use the new keyword on it, and then define a multi-line block using the do end keywords. And here to define our parameters, we can make use of the pipe symbols, so A and B. Now here, let me first place a couple of logs. So puts inside the proc, and then here we can say sum A plus B product A times B, and then print the sum of A and B is sum, and then here we can say product of A and B is product, and then here we can say coming out of the proc. Now just like we executed a lambda, we can call a proc as well. So on the result variable, we can chain the call method and pass to it the 2 arguments, which are the params, so 2 and 4. Now note here that these 2 arguments are being passed right here, which then gets used within our code block. So let us run the file to see what this yields. So this gives us inside the proc, and then it does these 2 computations. Then it gives the sum of 2 and 4 is 6, the product of 2 and 4 is 8, and then says coming out of the proc, and then it is done. So this is how you can tap into functional programming in Ruby using the concept of procs, lambdas, yield, and closures that we will see in just a minute. Now as a side note, there is no dedicated lambda class. A lambda that we declared right here is just a special proc object. Now if we have a look at the instance methods from the proc class, so we can say proc.instance method, and let us run the file. Okay, so this should be methods. You will notice that there is a lambda method inside the proc class instance methods. So this clearly denotes that a lambda is just a special proc object. Now a proc behaves a little bit differently than a lambda, especially when it comes to arguments. So if we call a proc without arguments, but we do receive them by using our pipe symbols and say 1 and 2, then here let us say 1 and 2, and then we simply call b.call without passing the 2 arguments. So let us see what this gives. So you can see we are just getting a comma, right? So for 1 we are getting nothing, then the comma, and for 2 also we are getting nothing. Now contrary to this, if I again define this, using the Lambda. So here we can say 1 and 2. And then if I print 1 and 2 right here, and then call b like this without passing any arguments and run the file, you can see for this case we are getting an error, but for a case of proc we are not getting any error, right? So here we are getting wrong number of arguments, and then run the file, you can see it's gone. So this is a very small difference between a proc and a lambda. Now another difference between procs and lambdas is how they react to a return statement. So lambda will return normally just like a regular method, but a proc will try to return from the current context. So let me demonstrate this with the help of a simple example. Let us say we have this code that returns something. First let us define using a lambda and then using a proc. Let us define a variable hello and here use our lambda to return hello, and then let us call it. So here I can say hello dot call. Now let us define the same thing using a proc. So instead of this arrow we can say proc dot new, and let me copy this line and paste it down below. Okay, so let us run the file now. So here you can see for the first call we are getting hello, but for the second call we are getting nothing, and the reason for getting nothing is that you cannot return from a top level context in case of a proc. Now if this proc was inside some method, then calling return like this would be equivalent to returning from that method. So let me demonstrate this. Let us say this is our method, so hello method, and here let us say before proc execution, and then let me copy these two lines and place them right here. And then let us say after proc execution, and then end this proc. So let us call our hello method and run the file. Okay, so let me comment this one and then run it. So here you can see we are getting the 2 3 from this call, then hello from this lambda, and then we are getting just before proc execution, and then when the control comes right here, it creates a new proc and returns from the proc. This return automatically returns us from the method as well. So we just return from line 647, and these two lines are bypassed. So we get before proc execution in the console. Now let us do a quick summary for procs and lambdas. Now lambdas are defined using this notation. So an arrow and a pair of parentheses if we want to pass arguments to our lambda, and then the code block like this. And for procs we use this proc.new and then our code block. Now for procs, the second thing is that it returns from the current method, whereas for lambdas we return from the lambda itself. Now we also saw just a while back that for procs they don't care about the arguments, right? Procs do not care about arguments, while lambdas raise an exception in such cases. So now we know what procs and lambdas are. Let us proceed further and understand about closures. Now procs and lambdas also have another special attribute. So when we create a Ruby proc, it captures the current execution context or the current execution scope with it. So this concept is sometimes called as closures, meaning that a proc will carry with it the values like local variables and methods from the context in which it is defined in, right? So they do not carry the actual values, but just a reference to them. So if the variables change after the proc is created, the proc will always have the latest version. So let me take an example. So def invoke proc, and to this we will pass a proc function. So here let us define a variable. Let us name this as counter and set this to 1. And then let us call the proc that we will pass in just a minute using the call method. And then we can end here. Now here let us define counter to as 0 and then define the proc function. So proc dot new, and here let us print the counter. So let us invoke our invoke proc function and pass the proc fn as argument. So let us run the file now. So in this example you can see we are having a local counter variable inside our invoke proc function, which is set to a value of 1. We also have this proc underscore fn and this invoke proc method or function, which runs any lambda or proc that is passed in as an argument via this call method. Now let us understand why we are getting 0 as the result instead of 1. Now this happens because the proc, which is this one, the proc fn, is using the value of counter from the place where the proc was defined, which is right here. So it knows its context and it is picking the value from that context, right, which is 0, and not from the place where it is getting called. So that is why we get 0 as the output. Now let us learn about a special class which is called as the binding class. The Ruby procs and lambdas store the scope information inside a very special class called as the binding class. So to create a binding object, we make use of the binding method, and this creates a binding, or you can say an anchor, to that point in the code. So whatever variable, method and classes are defined at that point will be available later via this binding object, even if you are in a completely different scope. So let us take an example. So let us define a method get binding, and here let us define a couple of variables, foo as 1, bar as 2, and then use this binding method. So right at this point we are creating a binding, or you can say an anchor, to this point in the code. So now we will be able to access foo and bar right outside our get binding method. So let me demonstrate this. So if I say get binding and use the eval method and to it say foo, and then puts get binding dot eval and bar. So let us run the file. So you can see this is giving us 1 for foo and 2 for bar. Now what if we try to print foo directly to the console and the bar as well and run the file? Then you can see we get error undefined local variable or method foo for main object. So it's a name error. So this will not work. And the reason for this is that the foo variable was never defined outside the method but inside our get binding method, right? And for this we can omit the invocation parenthesis as well, and even then we will get 2. So to sum it up, executing something under the context of this binding object is the same as if the code was in the same place where that binding was defined. So we don't need to make use of the binding objects directly, but it's still good to know that this is a thing, right? So in this section we discussed about what the blocks are and the differences between procs and lambdas. We also learned about closures, which happens whenever you create a block. So next up, let us talk about regular expressions. So regular expressions enable us to search for specific patterns inside our strings, and they are used to find and basically validate our data. So let us take an example to understand this. Let us say we want to validate a email address. So To validate an email address, we need to compare that particular string that the user provides as an email against an expression to find whether the provided email is valid or not. A regular expression is defined between two forward slashes to differentiate them from other language syntax. So the most simple expressions that match a word or even a single letter can be considered as a regular expression. Now let us say we are given a string, and let's name this as string1 and set this to I love JavaScript and Ruby. Now here if I say string1 and then use equals and the tilde operator and then define a regular expression. So use the forward slash and then let us say love and then another forward slash. So here we are simply checking whether the string that we have provided contains this word inside it or not. So if this string contains this word, so if there is a match, the code will return the index of the first letter of this word in this string, right? So let me print this to the console and run the file. Okay, so we are getting 2 here. The love word starts at index 2. So this is 0. Then this space is at index 1 and then L starts at index 2, right? Now if there is not a match, say if I say live and then run the file, then we get nothing, right? Now since this case is a very simple one, we could have used the include question mark method without specifying this regex. So we could even say puts string1 dot include and then use the question mark and then look for this word love. Now if I run the file, this gives us true because the word love is present within this string, right? Now let us see how we can write more advanced regular expressions. Now before jumping to advanced regular expressions, let us talk about a very important topic, which is character classes. Now a character class lets you define either a range or a list of characters that you want to match. For example, if I say A, E, I, or U, now this basically matches any vowel, right? So if you want to check whether a particular string contains a vowel or not, then to check that, we can define a function. So let us say includes vowel. And to this function, let us pass some string as an argument. So let us say string1. And here we can simply return string1 and then say equals and the tilde operator. And then here we can specify our regular expression. So here let us use the square braces first. And then we can say A, E, I, O, U like this and then end our method. Now if I say includes vowel and here let us first pass love, and if I say includes vowel, let us say node and includes vowel X, Y, Z. So let us print the result for each of these to the console and now run the file. Okay, so for the first one, we are getting index as 1 and this gives us the very first index where we get a vowel. Now you can see here we are having 2 vowels, but we got the index as 1. So it basically takes into account the first vowel and it doesn't take into account the amount of characters, right? Now if we see this one, here we get index 1 as well because E is a vowel sitting at index 1. And for this one we get nil or nothing. Now let us proceed further and learn about character ranges. So we can use ranges to match multiple letters or numbers without having to type them out all. So a range like say 1-4, this is equivalent to saying 1, 2, 3, 4. So let me show you this. So puts 1-4 and let us run the file. Okay, so here we are getting -3. Now the reason for getting -3 is that we are not specifying our 2 forward slashes. So now let us try this out. Okay, so now this is giving us something like this. Now let us take an example and check whether a particular string contains the numbers from 1 to 4. So if I say def contains number from 1 to 4, and here let us take a number, and then here we can say return number 1, and then use equals and the tilde sign, and then specify our character range from 1 to 4 in between the two forward slashes, and then here we can say end. So let us call the function contains number from 1 4, and here let us say 2 3 4 5 6, and then let us say 7 8 9 0. Let us print these two to the console and now run the file. Now for the first log we are getting true because the first character of this string, which is 2, does come within this character range, but for this string no character is a part of this range, right? Because the range is from 1 to 4, whereas our numbers in this string start from 7 and goes on till 0, but they do not include numbers from 1 to 4. Make sense? So we get nothing. So to sum this up, if you want to match any number from 0 to 9, then you can use the character range 0-9. If you want to match any letter from small a to small z, then you can say a-z. And if you want to match the opposite of this range, which means that anything that is not a letter in a-z range, so we can say first this operator and a-z. Now 0-9 is equivalent to \d. Now let us talk about wildcards. So let us take an example for this. Let us say we are given this string, so 7f4. Now here we want to use the dot or character which matches anything but new lines. So if we need to use a dot literal, then we will have to escape it. Now escaping a special character removes its special significance. If we don't escape it, so if we say dot match and use 2 forward slashes and then \d dot \d. Now here we are not escaping the dot literal, so let us print this to the console and run the file. Now here we are getting 7f4. So if we don't escape the dot literal, then in that case the letters will match. So if I copy this and paste it down below and then escape this dot literal by putting a \, prior to this dot, so right here, and then run the file. So now you can see we are getting nothing. And now in place of f, if I place a dot and then use the dot literal and use the \, and then run the file, this gives us 7.4, so it does match. Now let us proceed further and talk about modifiers in Ruby. Now up until this point we have only been able to match a single character at a time. To match multiple characters we can use pattern modifiers. So let us talk about some couple of modifiers. So first one is plus, which matches 1 or more characters at a time. Then we have the star, which matches 0 or more characters. Then we have question mark, which matches 0 or 1 character. And then we have something like this, where we use the curly braces, and then if we want something between two ends, so let us say 2, 4, so something between 2 and 4, then we use this notation. If we want something between 5 and 9, we use this notation, right? So we can combine everything that we have learned so far to create more complex regular expressions. So this means that we can have between 2 to 4 characters, and this means we can have between 5 to 9 characters, right? So let us solve a very simple question to check whether a particular string represents an IP address or not. Now with the given question, we will also be matching some invalid IP addresses like 999.999.999.999. But for the sake of an example, let us don't care about this. So let us say validate IP address, and here we will receive a string as the argument. Now here I can return a regular expression, so string 1, and use the equals tilde operator, and then we need to specify our pattern. So here I can say, so this symbol, and then we can say \d for the characters, \d, which means that we can only have numbers from 0 to 9, and then let us say 1, 3. So we can only have characters between 1 and 3. So we can have 1 character, 2 characters, or 3 characters, and then we need a dot, so we can escape that, and then we can again have characters from 0 to 9. So again 1 to 3 characters, then again we need to escape the dot, then \d, so for characters from 0 to 9, again between 1 to 3 characters, and then dollar to end this. So this represents beginning and this represents the end. Here I can place end. So let us call the validate IP address and pass a string, so 176.334.1.1. So we are escaping all the dot literals in our regular expression. We are also making sure that we have either 1, 2 or 3 characters prior to any dot. So let us run the file. Okay, so here we need to print this to the console. Let me remove this colon. Okay, so we are getting nothing. So to get something, we need to basically wrap this in parentheses and then apply double bank to convert this to a boolean. So let us run the file now. Okay, so we are getting a false. Okay, so let us see what the problem is. We need one more of this pattern. So here I will say dot d1-3. Okay, so now run the file. Okay, so we are still getting false. Okay, this should be comma, not hyphen. So now we are getting true for this one. Let me copy this and paste it down below and change this to say this and run the file. Okay, so now also we are getting a true. Now if I put an extra 0 here, this should give us an error because we do not allow 4 characters as per our regular expression. So we can either have 1 character prior to the dot or 2 characters or 3 characters but not 4. So let us run the file and we get false. So let us say we want to check whether a particular string starts with a particular character or not. So if we want to match strictly at the start of the string and not in between the string, we can make use of this operator, right? So here if I want to check whether this string starts with the or not, so here I can say this. So let us run the file and you can see we are getting the, right? To convert this to a boolean, we can put double exclamation marks and then run the file. Okay, so we are getting true because this string indeed starts with the. Now this was a brief introduction to regular expressions, and regular expressions are definitely amazing, but sometimes they can be a bit tricky. You can use a tool like rebuilder.com, and here you can pass a test string and your regular expression. So I will leave this link down below in the description section of this video. Okay, so let us now proceed further and talk about modules in Ruby. Now modules, as we know, are kind of a container that is used to group together methods and constants. Now contrary to classes that we discussed just a while back, we cannot create instances of a module. So modules can be used for namespacing. So let us take an example. Let us say we have a module and let's name it as computation. And inside this computation module, let us define a variable boy and set this to 3.14, and then to end the definition of the module we can say end, like this. Now there are a few different ways you can use modules. We can use them as a way to collect related utility methods and constants in a one centralized place. We can also include instance methods and constants from a module into a class to share the functionality. And then we can also include all the methods in a module as a class level method. So let us try accessing this pi constant. So here we can say puts, and first we could refer our computation module and then use the double colon operator and then say the constant that we want to access, which is pi. So this syntax here that you're seeing is used to reach out into nested modules and classes. So let us run the file, and you can see we are getting 3.14 being logged to the console. So using this double colon syntax can also be useful when you need to access the global namespace. So now let us proceed further and see how we can define a method within a module. So here let us say def, and let us define a method to double a particular number. So here we will receive a number as the argument, and here we can simply return number times 2 and end the definition of the method right here. And now to access or call our double method, we can say puts computation and then use the dot operator to call the method defined in the class. So this self keyword refers to our module. So we can say computation, which is our module, dot the double method that we want to call. And here let us pass the number as 45. So let us run the file now. Okay, so we are getting 90. Now in this case, for accessing a method, we don't need the double colon syntax because we are working with a class level method, right? So this represents a class level method. Now let me show you the use of the include. So here let us say we have a class named as calculator, and here let's say we want to include the module in our class. So including a module will give the class access to all the constants and the instance methods as if they were a part of the class itself. So included methods will always have higher priority than the superclass methods. So here we can say include computation and then place end here. And if I now say here calculator dot ancestors and run the file, this first gives us the calculator class, then it includes our computation module, then we further go to the object class, then to the JSON something like this, then kernel, and then the basic object. So this is the order in which it will look up. Let us see one more example for this. Let us say we have some module A, and let us simply end it right here. And then let us say we have a class B, and simply end it right here, class C. This inherits from class B and then includes the module A and then ends like this. Now if I say c.ancestors and print that to the console, can you determine the output for this code? So what should be the output for this code? So feel free to pause the video and think about it for a minute and then click play. So let us see the output now. So I'm getting an error for this one. It says A is not a module. So let me add a couple of characters here. Say let us say L, and here also. Okay, now this seems to work. So first we get our class, then we get the module which is AL that we are including within our class. Then it goes to B, and then from B it goes to some other thing which is A here. Then from A it goes to object, then this JSON thing, then kernel, and then the basic object. Now if you try this code locally, you might get a different output, but mostly the order should be same, right? So let us now proceed further and talk about the next topic, that is enumerable. So first let us talk about what is an enumerable. So enumerable is a module that is included in array, hash, range classes that we talked about earlier. So this module is composed of a number of very powerful iteration methods that we will see. So like each method that we discussed previously. So in this section, let us see some of the most interesting enumerable methods so that we can learn how we can include enumerable in our own classes to make them even more powerful, right? Now we can also implement or re-implement some enumerable methods on our own to understand how they work, and then we will see how we can work with more advanced features like lazy enumerators. So let us see this now. So let us first talk about the inject method. So using inject, we can apply some operation on every element that we have in a iterable, so like an array. And then we also need some kind of accumulator to store that result. So this is kind of similar to the reduce method that we have in JavaScript. So for example, if we want to sum up all the elements or all the numbers that we have in an array, we need a variable to hold that ongoing total. So that variable is called as an accumulator. The starting value for the accumulator can be the first element yielded by each. So let us see an example for this. So if I want to sum numbers from 1 to 5, here I can say inject and then define a code block and then use two parameters. So the running total, let us say the name is running total, or you can call this as accumulator, so ACC, and the current number. And then we can say ACC plus current number. So let us print the result for this in the console. So let me store the result in a result variable and print the result to the console like this. So this gives us 15, right? So let us now proceed further and see how we can make use of inject with a hash object. Now we can use the inject with hash because the hash includes the enumerable, as I mentioned just a while back. Now to see an example for this, let us first create a hash or a hash map. So let us first create a hash map items count and set this to an empty curly braces to begin with. So let us here add a key items count and let us name the key as pencils and set this to the number of pencils that we are having. So let us say 20 items count pens, 45 items count laptops, 3. And here let us first print the items count hash map. So here first I will use the double quotes and then interpolate this within the string. So current hash map. So let us run the file. So this is what we get. So pencils has 20, pens has 45 and laptops has 3. So let us now find the total number of items that we are having, which is 20 plus 45 plus 3. So for this, let us make use of the inject method. So items count, and on this hash table, we can make use of the inject method and let us start with a value of 0. And then let us define our code block. So we need two parameters here. So pipe symbol, and then first is our accumulator and the second one is our entry, right? So this complete entry. So we can represent the entry as a pair of parentheses and then the key and value, and then we can say ACC plus the value, right? Not the key. So ACC plus value. And whatever result we get back, let us store this in a variable count of items. So let us print the count of items to the console. Count of items. So let us run the file now and we get 68. Now what is the benefit of using this approach of using the inject method on the hash map? Now one, this makes it more clear that we are working with two separate variables, key and value, and then instead of having to guess what values are on what array indexes. Now since enumerable is a module, we can include it in our own classes so that we can have access to methods like select, map or inject available within our classes. Now to make this work, we will need to do one thing first. We will need to implement the each method in our class. Now this is important because all the enumerable methods that we have learned till now are based on the each method. So let us take an example. Let us say we have a class product repository, and this extends the enumerable module. So here let us first implement the all method that we get from enumerable. Now what the all method does is that that it checks if all the items or all the products in our case match a certain condition or not. So let me demonstrate this now. So here, let us first create a couple of products, and for this I will be using the structure, data structure. So a structure, so a new product, and here let us say a perfume. Let us take the price for this, 24. Then let us add another product, a shoe, $67. Then add another product, let us say Apple MacBook, 3000. Now this we need to pass in the all method. So self.all and then say end. Now let us implement the each method now. So we can say self.each, and then we need to iterate over this list of products. So let me say all dot, and here we can say each. So we are basically implementing the each method that we get from the enumerable module, and on this array we are using the each method to iterate over it, and then for each product we can yield that. And then end our class definition. So let us create a structure for product. So product struct dot new. So here we want the product name and the product price. Now here let us say we want only those products that have a price greater than 90. So for this I can say product repository. On the product repository we are able to access the select method because all the enumerable methods are now available to our product repository class at the class level. Make sense? So on the class we can directly call our select method and then define the code block, and then for each product I can grab the products whose price, so product price, is greater than 90. So let us run the file now. Okay, so this gives us a structure which is a product and says the product name is Apple MacBook and the price is 3000. Now we don't get other two products because their price is less than 90. Make sense? So now let us learn about how we can implement a map. Now let us implement some of the methods provided by enumerable so we can learn more about them, how they work. So we are going to start with a class. Let's name this as shop, and inside it let us set up a attribute accessor, so products, and then set up our initialize method and set our products property to this array. Let me copy this and paste it right here. Now let us end our method definition. So let me push it to the right, and here let us end our class definition. Next let us create a structure. So our product should be a structure with two properties, the product name and the product price. So implementing map method. So now for implementing the map method, let us name this as map, and as a first step let us create a new array. So let us name this as results and set this to an empty array. Now the first step is to iterate over the data, which is this data that we will be passing to this map method. So we'll pass our products as an argument to the map method. So products dot each, and for each product we can process that product by simply adding it to our results array. So by calling the yield on each product that we get in an iteration, and then return the results like this. So let us end here. Now the next step is to create an instance for shop. So shop dot new. Now on the shop we can call the map method, which is this one, but in order to call this we need to first place it right here within our shop class, right? So shop dot map, and to this we can pass shop dot products. So let me print this to the console and run the file. Okay, so it says already initialized constant product. Okay, let me comment this previous implementation and now give this a whirl. Okay, now since this method is inside our class, we don't need this argument, because earlier I defined this method right outside our class, but now we can directly reference our products property by using at here, and we can simply omit this. So now let us run the file now. So this is not working. So here we can say ampersand colon product name. So we basically want only the product names for each of our products. So let us now try this out. So this time we are getting the right output: a perfume, a shoe, an Apple MacBook. So this is how we can use this method like a normal map. So using the each method, we implemented a map method. And what the map does is, it takes an array of elements and transforms it into a new array. So earlier we had a products array in which each product was this object. So we transformed this array into an array of products with just the product name. So let me show you the array by wrapping this with double quotes and interpolate it like this, and then run the file. So here you can see we are getting an array of product names. So now let us proceed further and learn about the enumerator objects. So whenever we call the toEnum method on an object, so let us say if we call it on an array, so 1, 2, 3, 4, and we call toEnum on this array, we get a enumerator object. So let me wrap this in double quotes and use the string interpolation syntax. So the curly braces and a hash here. So let's print this to the console and run the file. So here you can see we are getting an enumerator, and this object holds a reference to the original object, which is this one. So the original object, it was called from, and also the method name that was used. So you can see it says it creates a new enumerator which will enumerate by calling method on object passing arguments, if any, right? So if a block is given, it will be used to calculate the size of the enumerator without the need to iterate it. So consider this example which is given here. If we have this string xyz and we say string.enum for and say colon each byte, so for each character it converts it to its ASCII code and gives us back a enumerator, and then if we iterate over that, then we get ASCII code for each of these characters, right? So this means that you can call enumerable methods on this new object that you get as if it was your real object. But if you call each, it will use the method that was passed as an argument to the toEnum, right? So let us take an example. Let us say enum and 1, 2, 3, 4, and here if I call select, and then if I print enum.class and then run the file, you can see this gives us the class of enumerator. So in this example, we generate or create an enumerator object by calling select without a block, right? So let us see what happens when we try to interact with this new object. So down here, let us say enum.each, and then for each number, I want only those numbers that are even. So number modulo 2 double equal 0. So let us print this to the console and then run the file. So here we are getting an error. Okay, so this should be number instead of numbers. Let me again run this. Okay, so now we are getting 2 and 4 being logged to the console. So we can see that using each acts as if we called select directly, right? So this happens because this enumerator object remembers what method it was created from, and it calls that method for us. Now remember that all the enumerable methods are implemented by using each in one or the other way. So in fact, this is the reason why you are able to call or chain your enumerable methods. Now the enumerator class also has something else to offer, which is the next method. So here if I say puts enum.next, and then let us do this a couple of times. So let us run the file now. Okay, so starting with 1, then we get 2, then we get 3. Let us again call this 2 more times. So enum.next. So now you can see first we get 1, then we get 2, then 3, then 4, and then after that if we call next, then we get this error, right? Iteration reached an end. So this is a stop iteration error, right? So using this next method, we can ask for the next elements that we have right after the one that got printed. Now after we requested the last one right here, if we again call next, there's no element after the last element, so we get this error, right? Now there is also a rewind method. So if I call puts enum.rewind and now run the file. Okay, so let me comment this first. And now if I say enum.next, so let us run the file. So the rewind method, what it does is that it lets us start over again. And when we say enum.next, then it starts from 1. Makes sense? Now let us say if we want to go over the possible values using next, then we can also make use of the loop method, which creates an infinite loop for us. But what is special about this loop is that the loop will stop once it finds a stop iteration exception without actually raising the exception, right? So loop, and here we can say puts enum.next. So let me set this back to 1 by first calling enum.rewind and then start from 1 again. So let us run the file. So right here, so for these 4 logs, we got 1, 2, 3, 4. Then we did a rewind. So we again start from 1. Then after printing 1, we again do a rewind. So we can again start from 1 with this loop. So this gives us 1, 2, 3, 4 in our console. Now before we proceed further to the topic of lazy enumerators, let us first discuss about exceptions. So now let us proceed further and learn about what are exceptions and why they happen. So exceptions are a mechanism to handle unexpected failures inside a program, and they typically show themselves in form of a program crash with an error message. So exceptions are used to signal an error condition when the program is not able to finish its work in the current state, right? So whenever a program raises an exception, it is saying that it got an error condition that it cannot resolve, and it is letting you know that it's your turn to handle it, right? So in Ruby, exceptions are implemented as classes, and all of them inherit the exception class. So in the documentation, you can find a list of all the built-in exceptions that you should check out now. Now you have probably seen exceptions a few times before, and they look something like this. So each error, the error message is composed of an exception class, an exception message, and the stack trace. So now let us proceed further and learn about stack traces. So let's go back to our Ruby tutorial file, and down here, let us define a function and let's name it as boy_cheese. And here let us say cheesebot. And end. Then here let us say boy chocolate, and here let us raise an exception with the message no chocolate left, and end this right here. And now let us say go shopping and call it right here. Now from the go shopping function we can call buy cheese, and then buy chocolate. So now when I run this, you will see we will get an exception. So let us run the file. So you can see we are getting an exception which says no chocolate left, and it's a runtime error because that was erased when these functions got executed, right? So now let us analyze it together so we can understand what is happening here under the hood. So whenever you get an error of this form, the first thing that you need to do is to look at the very first line, and it tells you where the error happened. So in this case it is on line 879 of main.rb, so main.rb colon 879 in the buy chocolate function. So it also tells us the name of the function where things went wrong, which is the buy chocolate. Now, next we also have two more parts that I discussed just a while back. So first is the actual error message, which is the no chocolate left, and then the exception clause, which is a runtime error. So these lines basically tell us the path of execution that the program took to get there, and it can be useful when the actual error condition originated somewhere along the path. So you can see that buy chocolate function was called by go shopping on line 885, and go shopping was called from the main.rb file on line 889. So now let us see more on exceptions. So an exception does not always mean that your program has to end, right? You can get trapped in an exception and just log an error message or do something to rectify that problem. So let us now try to read a file that does not exist, and in such case we should get an error, right? So let us say we have a file. So we are just assuming we have a file with the name 1.txt, which of course we don't have. So for reading the file we can say, so let us first open the file. So we can say file, and on the file class we have the open method, and try reading the file 1.txt. So since this file doesn't exist, it should give an error, right? Okay, so first let me comment this and now run the file. So you can see we are getting an error which says no such file or directory. So the exception in this case is errno double colon enoent, and the errno family of exceptions are all related to the operating system. So in context of a larger program, you may not want this code to crash just because the specific file does not exist. So to fixate this problem, what we can do is we can use kind of a catch block, which in case of Ruby is known as rescue, and catch the exception in that. So we can first try some piece of code by using the begin block, and here we can try reading the file. So 1.txt, let me comment this out. So we can wrap our code that raises exception with a begin rescue block, and here we can say rescue, and then let me copy this and paste it right here. Okay, so let me write this down, double colon enoent, and here we can simply log to the console file not found. And here we can end the begin rescue block. Now the code should print file not found if we execute this. So let us run the file now, and here you can see it gives us file not found. So using this begin rescue block, we can make sure that our program executes normally. Now the key here is this rescue block, which catches the exception that gets raised right on line 896. So this method tells Ruby to trap this exception or to catch this exception. Now if we don't specify this and then give this a val, then in that case a standard error is the default trapped exception. Now this will also trap all the exceptions that inherit from the standard error. So having a specific exception like this prevents us from trapping other exceptions that we didn't plan for, right? So it is important because it could hide a problem with your code if you just try to rescue. Now when catching an exception like this, you can also get the exception object, which contains the error message, the backtrace or the stack trace, and this can be useful for logging purposes. So to get access to the exception object, we can modify our rescue block to something like this. So here we can use an arrow, so equals to greater than, and here we can say ex. Now right after this log we can say puts ex.message, puts ex dot backtrace. So if we now run the file, you can see we get first the file not found, then the error message which is no such file or directory, and then we get the stack trace. Now for the stack trace, it always happens in reverse order. This means that the most important line will be the last one instead of the first one. Now we don't always need this begin keyword. Instead of this, we can simply omit this and define a method or function which says open file, and then call it from right here. So open file like this. So if I now run the file, you can see this works fine, and we are still getting that exception because our file does not exist at the moment. Now instead of this, if I try to read a file that already exists, which is items.csv, and run the file, you can see we get no exception, right? Because the file got successfully opened because it already exists in our working directory, right? Now we can read this content by using the read method. So let us try logging this to the console and now run the file. So you can see now we are able to successfully read the contents of our items.csv file. So first is our header row, then our row pertaining to pencil, then pen and laptop. So now let us try to read the content of this file and write it into some new file. So for this, we can store the content that gets read from this operation, and then we can call file.write and then write the content to a new file that will get created on the fly. So let us name it as items copy.csv. And now let us run the file. Okay, so there is a problem in this. It should be this. So first the name of the file and then the content that we want to write to that new file. So let me run the file real quick. Okay, so now this works. Let me remove this one. So you can see this works. Now another keyword related to exceptions that you should know of is the ensure keyword. Now the code inside the ensure block will always run even if an exception happens. So this can be used to clean up resources or any cleanup task, or you can place that code that you want should always run, right? So here let us define the begin block, and here I could print inside the begin block, and then I could add the ensure block right here and print I will always get executed, and then we could end here. So let us run the file now. Okay, so first we get inside the begin block and then I will always get executed, right? Now we can also create our custom exceptions. So right here in this article you can see this shows a class which is permission denied error that inherits from the standard error class, and then you can raise a permission denied error using this syntax. So here you can see we are having a attribute reader which is for this action property. So whatever error message gets raised here, which is the permission denied, gets passed to the constructor. So it calls the constructor of the superclass, which in this case is standard error, to set the error message, and the action is set to delete, which we store in this instance variable. Next, if we talk about the class hierarchy, so every error class ultimately finally leads to this exception class, right? So we have exception, and then within it we have no memory error, then a script error. This serves as a superclass for load error, not implemented error, and syntax error. Then right on the same level of script error we have signal exception. Now within standard error we have the IO error, argument error. We also saw the type error. So I will leave the link for this article down below in the description of this video. So this was it for the exceptions section. So any program that raises an exception does so in an unexpected situation, right? And this lets users of our program to find where the problem occurred. Now if an exception is not handled, then your program will crash with an error message and a stack trace, right? So let us now proceed to our next topic, which is lazy enumerators, right? So I'm on the Ruby docs, and here you can see enumerator : lazy. This is a special type of enumerator that allows constructing the chain of operations without evaluating them immediately and then evaluating the values on as needed basis. So you can see we can apply a chain of operations that we want to perform by first applying this lazy method. So let us take an example for this to understand it. Back to my editor. Let us say we want to do something with a given array, like figuring out if all the elements meet a certain criteria using the all method that we discussed previously. But let us assume our original array contains large amount of data. So if we do some operation using map and all method, so let us say we have a array of elements. So let us create one by specifying a range from 1 to say 10 lakh, and if I say array elements dot lazy, and then on this if I call the map method, and for each number let us raise it to the power of 2 and then apply the all method. Now for the array that we get as a result of this, we want to check for the condition whether all the numbers are less than 500 or not. So what will happen here is that this map and all will process the entire array at least once and most likely twice with this all. So this all method will return false as soon as it finds an element that does not match this criteria. But for this case a very special thing will happen because we are using the lazy method on our array elements. So what will happen here is that when you call lazy prior to calling the map method, we get an enumerator lazy object, and this allows us to do a partial mapping and only get the amount of results that we need. Now this all method then will ask map for one item at a time and stop as soon as one of the elements does not match this criteria, which will save your program from doing a lot of work, right? So to see this in action, right here I can call puts object.inspect and now run the file. Okay, so this should come first, then a semicolon right after this console log, and then this operation of raising a number to the power of 2. So let me run this again. Okay, we don't need a space here. So let us run the file now. So here if we run the file, you can see here we are printing the number. So we start from 1 and we go on till 23. Now instead of this, if I simply remove this lazy and then call this code and run the file, you can see it keeps on running and this will not stop till this big range. So let us exit this now and let me add lazy here and rerun this. Okay, so from 1 to 23. So if we take away lazy, then every number will get printed, right? But since our range is too large, therefore it will take a lot of time to process each and every element within this range, right? So this lazy method helps us to process as many elements as necessary and not more, and that is why it is called as lazy. So this was all I wanted to cover about Ruby in this short course on Ruby. So if you liked the video, do give it a thumbs up or comment down below if you have any queries. Please don't forget to subscribe to my channel, and I will see you guys in the very next one.